Hello guys, how are we doing today? This is Little Black Belt, and today we're going to be talking about relational operators and conditional statements in our fourth tutorial in C++ for beginners. So last time we talked about user input, and we're going to practice that a little bit today, but relational operators and conditional statements are huge in programming no matter what language you're working with. It's very paramount that you understand how this stuff works, and at first it may seem a little difficult if you haven't worked with this kind of stuff in math. Relational operators you guys should be fairly familiar with, but conditional statements might be a little bit tricky at first glance. But we're gonna get that straightened away, and hopefully you'll have a basic understanding of how that works after we do some examples today. But first we're going to talk about relational operators. So why don't we just focus our attention to this top proportion of this little text file here. We have the relational operators within C++. This first one is equals to. If you remember a couple tutorials back, I was talking about the difference between the assignment operator, which is just a single equals sign symbol used to assign a value to some variable, versus this, the equals to. This is actually checking whether something is equal to something else, right? So this is it's used for comparison, right? And then this one here below it is simply the opposite. It's checking to see if something is not equal to something, and you indicate by just having a little exclamation mark. And typically in programming, this exclamation mark means the opposite, right? And we'll talk about that a little bit later when we get to compound conditions. I will warn you, this tutorial might be a little bit longer than typically because there's a lot of stuff to talk about in this, but it's very important, so it's good to know. Then less than, greater than, you should be familiar with this from math, and then less than equal to and greater than equal to, right? And these can get confusing on which side of the equal sign this has to go on. It's always on the left, so. And the way we use these is typically in conditional statements, so now we're going to move on to this part down here. So this should be fairly easy to understand, and if you don't totally get it, we're going to use an example here in a minute, so you should be able to see how we use those. But typically they're used in what's called conditional statements, right? And these usually take the form of you say if, and then you have the condition here, and then if it meets that condition, then it performs this statement. So it only performs the statement inside this if condition if it meets this condition, right? And then in the end, there's also, if you want to add on to it, there's an else. So if you want it to do one thing versus another, right, it can decide which of the things it wants to do. And we make these kind of decisions in life all the time. For example, if it's sunny outside, then I'll wear shorts. Else, I'll wear pants, right? That's very simple. We make these kind of decisions in our life all the time. You don't even really think about it. In programming, it's sort of brought out to the front, and you have to think about it. So let's do a little simple example. And we'll start off with just an if condition, if statement by itself, and then later we'll tack on an else. And there's actually something called an else if, and we'll get to that if we have time today. But it's a really simple concept, and it's not much different than just the typical if and else. But so here's just a little outline of C++ code here. We've got the basic stuff that we're going to need for this little mini program that we're going to write, and we're just going to test out the conditional statements and whatnot. So let's create an int x, okay? And what this is going to do is we're going to have the user input a number, okay? So we're going to practice using cin that we talked about in the previous tutorial, and then we're going to check whether that number is 0, right? That's all we're going to do, and if it's 0, then we're going to print out the number 0, okay? And that's all. This is going to be a very simple program. So, int x, and why don't we just cout, enter a whole number, okay? Just, to make the program look a little bit better. And we will cin x, okay? Now here's the new stuff. You say if, and you'll notice it lights up. Little keyword here. If x equals 0, okay, and then we use these brackets to indicate the code that we want to create within this if statement. And you should know that if the statement inside this if condition is only one line long, you don't need these brackets, but I'm going to put them in this example just because it's good practice. And notice there's also no semicolon at the end of this statement. You just need the brackets to indicate the code that's going to happen if this condition is met, right? So everything inside here is only going to execute if it meets this condition, if x is 0, right? So we're just going to see out the number that you input was 0. Okay? That's all we're going to say. The number that you input was 0. And then that's going to be the end of the code. So we're going to compile that. And it's going to ask us to save it. We're just going to say new.cpp. Oh, I want it on the desktop though, not computer. And good, we compiled, no errors. So I have my command prompt already ready, and we named it new, so I'm going to execute that. It's going to ask us for the whole number, and I'm going to input 0, so it should tell us that the number was 0. The number that you input was 0. Perfect. Now say we run it again, and I input a different number, like 2. It's just going to quit the program. See that? It didn't execute anything because this condition was not met, right? So that's very simple. Now let's add an else statement, right? So if I want to say an else statement and say the number was not 0, for example, then we can just do this, right? Again, we're going to use these brackets, so these brackets indicate that the following code in between these two brackets will only be executed in this else statement. And what this else statement says is that if this condition isn't met, then execute this condition. So now it's going to either execute one or the other. If x is 0, it's going to tell us that it's 0. And now we're going to tell it to say the number is not 0. Alright? Very simple. Let's run it again. And new. Enter a whole number. We'll try it with 0 again. The number that you input was 0. Let's run it again and say 2 again. The number was not 0, right? So it's very simple, really easy to understand. It's going to execute one or the other, if, else. Okay? Now let's spice it up a little bit and make this a little bit better. Okay? We're going to want it to say whether it's 0, positive, or negative. Okay? And we're going to do that using else if, because you use else if when you only want it to check one condition. Okay? If we say if over and over again, you say 3 if statements in a row. Say we say if x equals 0, then tell the user the number that you input was 0. And then under that you say if x is greater than 0, then say the number was positive, and then say if x is less than 0, then the number is negative, right? Well, you don't see it happen, but the computer's actually going to check each of those if statements, okay? Well, there's no need for it to do that, because we know that a number is either going to be positive, 0, or negative. You know, it's not going to be 2 at the same time. It can't. I mean, 0 is weird, but we're going to check, for 0. So you either know it's going to be positive or negative. It can't be both at the same time, right? And so there's no point for it to check that and use up that extra bit of efficiency checking that if we don't need it. So let's modify this a little bit using else if statements. Sorry. Let me put that back. All right. Then we say, the way we indicate an else if is pretty much how it sounds. It's else if, right? And then we need to have a condition here because it is an if statement. And we'll say if x is greater than 0, and then these brackets indicate what's going to be performed. We'll say the number is positive. Okay? And then after that, we're going to do another one. Say else if, and then the opposite, if x is less than 0, and then put the brackets, and extra space there. See out the number is negative. Alright, super simple. So it's either going to perform one or the other. And say it meets this condition, then it's not even going to check for these because these are else ifs, right? And then say if it checks this condition and it's not true, then it's going to move down to this one. And if that one's true, then it executes that one and skips this one altogether. However, if it's the case that this condition is true and these are false, it's going to go through the previous conditions until it meets that last one. So in that case, if it is the last condition, then you don't really save any efficiency because this is checking all of them. But say if it performs the first one and this is true, then it's just going to skip these, right? You get a little bit of efficiency out of it. So let's compile it again, run it, and we'll check each of the 3 scenarios. Let's check if it's 0 first. We'll input 0. The number that you input was 0. Let's run it again. Enter a whole number. We'll say 5. The number is positive. And one final check. Enter a whole number. Let's try -9. That number is negative. So there you go. Checks whether it's 0, positive, or negative. Super simple program. Right? So that's just showing a little bit about if and else statements. So, and this is really paramount to understanding programming and being able to write a program. You'll need to know conditional statements because think about how many times we use them in the real world scenarios. You make these decisions all the time, even though you don't think about it. But you got to tell the computer to do it now. So now we're going to move on to the final part of today's tutorial, and that is compound conditions. Okay, and this, well, it's not too much more difficult than this. It's just essentially the same thing. There's still a condition here, but there's going to be sort of 2 conditions that make up one bigger condition. And you can have more than 2, but I'm only going to do 2 today. And you do that with and, or, and the not operator. We already talked about this one a little bit with the not equal to, but this basically is switching whether it's true or false. This is how you indicate and this is how you indicate or. Okay. This is that little vertical bar. It's right under your backspace or delete key on your keyboard, right above the enter key or the return key. And this is just that vertical line. You press shift and you get it. Typically you don't even really use it, in regular typing. I can't really see why you'd ever use it, but yeah, it's that vertical line. I don't even know what it's called. It's like a pipe. I don't know. Anyway, you use these to separate the conditions that make up the one compound condition. Okay. And so let's show an example of that. Go here. And let's make another integer y. I'm going to say enter a whole number x so that we can separate these. We're going to cin x and then cout enter a whole number y. Okay. And then of course cin y. So now we've got 2 integer values that we are going to have. And now we're going to make a compound statement with those. Alright? So say you want to execute a piece of code and you only want it to execute if x and y are both positive. How are we going to do that? Well, we're going to use the AND operator, and this is when you kind of need to understand truth tables, and so I'm going to move this tab over here because I have a little bit to explain, and this might be a little tricky to understand at first, but this is what's called a truth table, and this is the truth table for AND. This symbol here means AND in the math world, but it's essentially the same as the double ampersand in C++. It's basically this. It's AND. Okay? So we can see this is basically a compound condition right here, right? You got one part of the condition P, the other part Q, right? So say one evaluates as true and the other evaluates as true, the condition is true, okay? This is like going on a roller coaster. Say you have to be a certain age and a certain height, right? If you meet the conditions for the height and you meet the conditions for the age, then you can go on the roller coaster. But say you meet the conditions for the height but not the age, then you can't go on it. The only way that this evaluates as true is when both are true. If either one is false or both are false, then it evaluates as false, okay? Just think about the roller coaster. You have to meet both conditions. You can't just meet one or the other. And obviously, if you don't meet the height or age requirements, then you definitely can't ride the roller coaster. And the other one, which I was talking about, is the or. Oh, shoot, that's really small. Maybe I can zoom in on it here. Okay, I got a little bit better. Anyway, the or is just the same thing but flipped upside down, and that's the same as this in C++, this little double pipe thing. And so with or, it's different. You only need one condition to be true for the whole thing to evaluate as true, right? This is like your wife tells you to go buy cookies or ice cream at the store. If you come back with cookies, she's going to be happy. If you come back with ice cream, she's going to be happy. If you come back with both, she's going to be happy. But if you don't come back with cookies or ice cream, she's probably not going to be very happy, right? You got to please a woman, right? Give her the cookies or the ice cream. So this is the same thing, right? Cookies and ice cream, she's going to be happy. You buy the cookies but not the ice cream, she's still going to be happy because she said cookies or ice cream. If you buy the ice cream and not the cookies, she's going to be happy. But if you don't come back with the ice cream or the cookies that she asked for, then you're in for a rough night. You're probably going to be sleeping on the couch. So that's basically how OR works. And so if you want to read more about that, I'm going to have a link in the description that you can look at, because I know it's a little bit hard to understand with me talking to you, and you might need to read about it yourself a little bit. But that's what I'm going to say about that. Now, if we go back to Notepad++ here, we're gonna practice the AND operator. So we're gonna do the same setup here. We say if, and like I said, we want to check to make sure they're both positive. So we say if x, we say if x is greater than 0 and y greater than 0. Okay. So here's one condition, the other condition, right? And this whole thing is only going to execute. Let me put the little brackets on there so it's a little easier to see. That whole thing is only going to execute if both of these are true. Because remember what I said about the AND, both conditions have to be met. You have to meet the height requirements and the age requirements, right? If you just meet one and not the other, then you still can't ride the roller coaster. So then we're going to see out both numbers were positive. And we're going to put the exclamation mark because we're extra happy that both of those numbers are positive. Okay? So this only executes if x is greater than 0 and y is greater than 0. And when you're first learning code, it might be tempting to say something like this. If x and y greater than 0, this this doesn't mean the same thing, okay? And you'll notice that it does compile, but basically what this is going to do is, if you remember from when I was talking about Boolean values, that a 0 is false and a 1 is true, right? And so basically if you put a 0 in here, it's going to evaluate as false. If it's anything else, it's going to be true. Or maybe that's backwards. I don't remember. Actually, let's test it. So we'll pull this up and execute that program, and it's going to prompt us for a whole number x. We'll say 0, and we'll say 6, and it didn't execute it because this means false, and so this evaluated as false and true, and so that didn't let us execute that. Now I'm curious, because I forget, if we enter 6 and 6, the numbers were both positive because 0 is false and every other number is true for x. So that's how that works. So if you put a 0 for x, that evaluates as false. If you put any other number, it evaluates as true. Just a little tip. It's easy to forget. In fact, I forgot it myself. But this does not mean the same thing. You can't, if we say it in real life, we could say if x and y are greater than 0, and the way we say that implies that both x is greater than 0 and y is greater than 0, but you can't say that in programming. You have to break it up and say if x is greater than 0 and y is greater than 0. That's just how you got to write it. It just takes practice because it's not the same as how you would say it. Typically, you wouldn't say it like that. You'd break it into the shorthand version, but let's compile this and give it a run here. So if we put a 0 for x and a 6 for y, it's not going to do it because x is not greater than 0. And as you can see, it didn't execute any code. It just quit the program. But if we say 8 and 7, it tells us they're positive. Okay? And it wouldn't do it if we put a negative either, because that is obviously less than 0. And we can also just use an else statement in here too if we want to say that and say at least one of the numbers was less than or equal to 0. Okay? So, because obviously that's the case, if this doesn't execute, then one of those numbers has to equal 0 or be less than 0. And so I'll compile that and show you that. Now it should run that extra bit of code there. If we say 0 for x and 5 for y, and at least one of the numbers was less than or equal to 0, and that's true because x was 0. And as you can see, if both of them are, we'll say, I don't know, -8 and -5, it's going to do the same thing. At least one of the numbers was less than or equal to 0. So this is what's known as a compound statement, and I can show you with OR as well. We use this operator. Now it only cares if one of them is positive. Okay, so we'd have to change this statement here. We'll say at least one number is positive. Okay, and then for this one, we can say neither number was positive. Is that how you spell neither? I don't think the I is, I think it's like that. No, that's not like that. That's how you spell neither. Okay, so now if we run it like that, and if we just make sure one of the numbers is positive, say this one, and we give that a 0, and it says at least one number is positive. It only cares that one is positive. Okay. However, if we make them both 0 or negative, say 0 and 0, then neither number was positive. They both evaluated to false. So yeah, that's how that works. And the I'll go over it really quick since we're already way over time. I'll go over the not operator as well. This simply is just going to switch what this evaluates, and what you got to do is just put an extra little parenthesis around it, because we're going to say, we're just going to tell it if not this whole thing. Okay, so this is the opposite. So what is this going to say? This by itself, x greater than 0 or y is greater than 0, is going to say at least one number is positive. So if not at least one number is positive, then this is going to be both are negative, right? So both are negative, and then this is going to be at least one is positive. It's just switching it, right? It's going to switch this. It's saying the opposite of what it was before. And so if we run this, if we give it two positive numbers, at least one is positive. If we give it one negative number and a positive number, at least one is positive. But if we give it, say, two negatives or that are 0, I guess I didn't indicate that. These don't necessarily have to be negative. They could be 0 as well. Just because I have that in there, I should have said that. But yeah, anyway. If we enter two negatives or two zeros, so let's say 0 and -5, both are negative. So yeah, this basically just switches what this would evaluate to. So if this statement evaluates as true, then this is going to make it false. And if this evaluates as false, then this is going to make it true. It just switches it. Okay, so that's how you use that operator. It's whatever to the right of it is going to switch what it turns out to be. So yeah. So that's going to wrap up this tutorial. Pretty soon we are going to be ready for our first little mini assignment. I'm going to be coding along with you, actually. We're going to basically be working on a calculator. It's very, very simple. A lot of people use it as one of their first real programs, and we almost have the knowledge to do it. In fact, with one more tutorial, we could have the knowledge to do it. It just depends. There's a couple different ways you can. One is with a while loop, and the other is with, I guess you could do it with a for loop too. You can do most of the same stuff with a for loop as you can with a while, or you could do it with what's called a switch statement, but you'll still need a while loop for that. So I guess we could just do it with a while loop and cover the switch statement afterwards. I don't necessarily have a plan, but we'll get there. So that's what we're going to do. We're going to be, in the next couple episodes of this tutorial series, we're going to be creating our first program, and it's going to be basically a calculator, which is exciting. So be ready for that. I'm going to be coding along with you, but I'm going to be doing periodic pauses in the video for you to do the code and then compare it to what I've got. Should be fun and a great way to test your skills and see what you've learned. So that's all I'm going to have for you today. So thanks for tuning in. I hope you learned something. I'm going to include a link in the description. It's going to be to the C++ tutorials website where you can read about the stuff and get a little bit more in-depth view about the information that I cover in these videos. But yeah, it should be great. If you never need to learn a little more, or you want to get a more in-depth idea of what I'm talking about, because I go over it pretty briefly, then definitely Google it. I usually include a link in my descriptions that links to a page similar to the stuff that I talked about that you can check out. So that's going to be it for today. So I appreciate you watching. I know this was kind of a long video. I apologize, but this is a big topic that you have to learn. So thanks for tuning in, and this is Little Black Belt out. I'll see you next time.